Alright, so today our learning target has kind of switched from just simplifying rational expressions or doing multiplication and division. Okay, multiplication and division was definitely the easier of the two. Alright, all you got to do is factor it, cross off your common factors, things like that. Now we're switching to adding and subtracting rational expressions. Okay, I'm going to start by going back, okay, to when you had to add fractions in junior high or 4th, 5th grade, whenever it was that you started adding fractions. Okay. What makes adding and subtracting more difficult when you're working with rational expressions is you have to have common denominators. When you're multiplying and dividing, it doesn't matter. Okay? But adding and subtracting, you have to have common denominators. So that's what makes it a little bit more challenging. If I go back to how we add fractions here, okay? 2/3 plus 4/7. Okay, we can't add right now because they have different denominators. What do I need to do to make them have the same denominator? Or what will that same denominator be? Yeah, multiply the denominators together, right? Take 3 times 7, which is 21. So make both denominators become a 21. So now here's kind of my thought process on that. Okay? I want to make the denominators the same, so the easy way to do that is just multiply them together. Now, sometimes you don't have to multiply them together, because sometimes you only need to change one of them, right? Like, let's say you had 3/4 minus 1/12, or something like that. Okay? Well, here, I wouldn't multiply the denominators together. You could, right? It's okay.
Couldn't you just do times 3 and then times 3 and then...
It'd be easier to just make this one become a 12, right? Instead of having to do something to both of them. So keep that in mind too. But a lot of times the easy way to do it is simply multiply the denominators together. So if I want to make these denominators the same, I would need to make both denominators become 21. To do that, what do I have to do to this fraction? Times it by 7 over 7, right? And I got to multiply it times 7 over 7 because I got to do the same thing to the bottom as I do the top, because otherwise it changes the value of the fraction, which would change the problem completely. Okay? For this one over here, I need to multiply by 3 over 3. Okay? So then when I do that, I get 14 over 21 plus 12 over 21. Okay? Now I have the same denominator, so now I can actually add the numerators together. 14 plus 12 is 26. The denominator stays the same, and 26, 21 over 21 would be the answer to that fraction. You don't need to, you won't need to change things to mix numbers or things like that, because you'll be working with variables. All this, numbers will be gone, you'll be working with variables for the most part. Okay? So, good refresher on fractions? Okay. So, I'm actually going to do a couple problems with you from that link.
You think this is harder than the fraction ones?
Yeah.
Oh. Carrie, if I were going to do that. Yeah. Oh god. That's like 3rd grade stuff. Yeah.
Alright, so, I'm going to start with a subtraction one here. Okay, I'm going to start easy, and we'll find a more difficult one. So, they were really nice to you at the start of this document. Okay? They already have the same denominator. I'm going to do an easy one, then I'm going to jump to a more difficult one. Okay? These already have the same denominator, so all you need to do is subtract the numerators. But I'm choosing to do this one because this is where a common mistake occurs. I have to take this numerator and subtract this numerator. You need to make sure you distribute the minus sign to this entire numerator, because this entire numerator is being subtracted. So essentially you have m minus 3n minus m minus 3n all over your common denominator. Right? Because the denominators stay the same when you're adding and subtracting, correct? So I don't change my denominator. So I have to take this minus this. So I took that numerator and I subtracted that entire quantity. Another way to think of it is you're doing m minus 3n minus m plus 3n. So you have to distribute that minus sign. Okay? Combine your like terms, what do you get? We're subtract. We're not multiplying, we're just adding and subtracting here. Negative 6n over 6m cubed n.
What about the m on the top? Yeah.
What is m take away m? 0. We're not multiplying now, we're just adding and subtracting. So we're 1m minus 1m is 0m, or 0. A negative 3n minus 3 more n would be negative 6n.
So you have to distribute the negative before you can... Okay.
Yep.
So that's how you got rid of the m.
Now let's simplify. The 6 cancels, the n cancels. I'm left with what?
1 over m.
Negative 1 over m cubed. Okay? So that was a pretty easy one. The denominators already started the same for you. All you had to do was subtract the numerators. But again, be careful, please. Make sure you subtract the entire numerator right here. All right? I'm going to find a tough one. Alright, we'll do an addition. We'll do an addition. But it's definitely a little tough. That noise, by the way, is that person right there. She'll be famous someday. That's on YouTube now, by the way. Alright, so this one, clearly they don't have the same denominator. One of these fractions, though, can actually be simplified. And if you can simplify fractions first before you go into the addition, I would.
Second one.
Okay, the second one, yep. Okay, it'd be like this, guys. If you had to take, oh, I don't know, 3/4. Bad marker. If I had to take 3/4 plus 2 24ths, okay, I would probably simplify that first before I go to add them. All right? So if you look closely here, 4n over 2n plus 6. If you factor the bottom, you get 2n plus 3, right? So now what can simplify? The 4 over the 2 would reduce to 2 over 1, right? Does everybody see that?
Yes.
Now, what if you didn't catch that right away? Just means you're going to have more simplifying at the end of the problem. Okay? It's okay if you didn't catch that right away. But I try to simplify things first if I can, because that'll probably save me some extra simplifying on the back end. Are you guys okay with this?
Yeah. Could you cancel the n?
Nope.
No.
Because it's n plus 3. It's not n. Yep. Good question. You cannot cancel the n because the bottom one is n plus 3.
But what about, it's like 4n and then 2n? You still can't do that?
No,
Before you.
because it's a 2n plus 6. It's not written as factors. So again, let me show it to you this way. 4n is like 2 times 2 times n, right? And the bottom is like 2 times n plus 3. So on the top, my factors are 2, 2, and n. On the bottom, my factors are 2 and n plus 3. You can only cancel common factors. So I can only cancel the 2's. I can't cancel the n because I don't have just an n as a factor in the denominator. Good? Okay, so I'm going to rewrite the problem. 5 over n plus 5 plus 2n over n plus 3. Now, my denominators are different. Okay? In order to make them the same, the easiest way to do it is simply multiply them together. Okay? So my common denominator is going to be n plus 5 times n plus 3. Okay? So I need to multiply this fraction.
So is it n squared plus 15?
I need to multiply this fraction by what? N plus 3. And I need to multiply this fraction by n plus 5. Just like when we multiplied those, the 7 over the 7 and the 3 over the 3 to start the day, right? Okay? So now I have, and some of you won't write this step, some of you will do some math already, but now you have 5 times n plus 3 over n plus 3, n plus 5.
Do we write it like that, or can we actually like?
Plus, you can do that, I'm just not trying to go too fast here. Okay? Plus 2n times n plus 5 over n plus 3, n plus 5. Okay? I haven't actually done any multiplication yet, I just have written it as products for right now. Now what I will tell you is, I don't multiply the denominators out. I leave them as factors. Save me some time, plus if something can simplify at the end, it's going to be easier to see it if I leave these as factors. So I leave the denominators alone, I just leave them as a product. I don't actually get the product, I just leave them as factors. Okay? But now in order to add, if I need to add this numerator with that numerator, I need to distribute. Okay? So what's 5 times n plus 3?
5n plus
5n plus 15. What's 2n times n plus 5?
2n squared plus 10n.
Now am I ready to add my numerators together?
Yeah.
I have common denominators. So now I just need to add what's on top, add the numerators together. So find all your like terms, right? Well, the only like terms I have are a 5n plus a 10n, right?
Well, can't you factor?
2n squared plus
Factor what?
Uh,
Why do I want to factor this? That would just put me backwards a step,
yeah, okay.
right? Aren't I trying to add these together to write my answer as one fraction?
Yeah.
Okay? So, I mean, we're ready to add.
Yeah.
We got common denominators and we're ready to add all the stuff on the tops together. So this plus that, okay? What do I get? Right in the correct order.
2n squared plus 15n plus 3.
over.
N plus 3, N plus 5. Right? 2n squared 5n plus 10n is 15n plus my 15, and I just put it all over the common denominator. Okay? Now the only thing you do need to check at this point is see if you can factor the numerator, because if there's a common factor on the top as there is the bottom, you'll be able to cancel that out. Okay? So, quick refresher, how do we check to see if we can factor that? Take a times c, okay? Well, yeah, look for a greatest common factor. You're not wrong. Look for a greatest common factor, but there isn't one here. Okay? Take a, the leading coefficient times the constant, 30. Are there two numbers that multiply to 30 and add to 15? Well, 1 and 30, that won't work. 2 and 15, that won't work. 3 and 10, that won't work. 5 and 6, that won't work. So that tells me that this is not factorable. So since this is not factorable, there obviously is not going to be a common factor that will cancel with either of those factors down there. I would leave my answer just like this. If that bothers you and you want to distribute the denominator out, you go for it. But why take the time to do it if I'm not making it?
So if there happened to be like an n plus 3 on the top, you cancel it.
Yeah, absolutely. Yep. If this was factorable and one of the factors was n plus 3, absolutely, you need to simplify it.
Okay.
Yep, good question.
And if it was factorable and it wasn't one of those, you'd still have to factor it?
Wouldn't have to.
Okay.
Nope. Any other questions?
Do we have to figure out the zeros on those things? Like what is not?
You could. I could say,
Like
you know,
-3.
what's the sum of this and what values can n not equal? You know, so yeah, n cannot equal -3, n cannot equal
We're
-5.
not doing that one?
I forget the directions, but I could ask you that.